Hi guys, this is problem number 16 from the test you just took, and I wanted to go over this because a lot of you guys had trouble with this question. It is one of the highest point valued questions on the test, but it is a challenging problem because it's one of those problems where you need to adjust the domain to fit the new angle that's being represented. So I wanted to walk you through this just in case you saw something like this again. So most of you guys didn't have too much trouble when you started off this problem by getting the sine part by itself. So, by adding 2 to both sides, most of you guys came up with 4 times sine squared of x plus pi over 3. Then most of you had no trouble dividing by 4, coming up with sine squared x plus pi over 3 equals a half. And most of you guys took the square root just fine. Keep in mind that when you're taking the square root of a half, since we're introducing the square root, I need to write both the positive and negative versions of that number. Now the square root of 1/2, I'm going to write that as positive and negative root 2 over 2 so that I can find it on the unit circle a little bit easier. All right, so we're going to go around the unit circle now, and we're going to find what angles have a sine of square root of 2 over 2. So I go over to my handy dandy unit circle on this side, and I'm going to look at the sine, which is the y coordinate. So I'm looking for y coordinates that are equal to square root of 2 over 2, either positive or negative. So if I'm going to start at 0, I'm just going to crank around the unit circle and pick up any time I see a square root of 2 over 2. There's one. The first time that happens is at the angle pi over 4. So pi over 4 is going to be a place where the sine equals square root of 2 over 2. I'm continuing to check y coordinates. There's another spot. 3 pi over 4 is the second location on the unit circle. If I keep on going, I see a negative square root of 2 over 2. That's at 5 pi over 4. Let's see, and another one, there's a final one at 7 pi over 4. Now I could keep on going around the unit circle and picking up more and more and more solutions. I could go beyond 2 pi and just keep on adding quarter pies at a time. But this is where the domain comes into play, because our original domain tells us we need to find solutions for x, so that x is between negative pi and pi. But the angle that we're talking about is not just x, it's x plus pi over 3. So what would be the domain for x plus pi over 3? Well, I just need to add pi over 3 to each one of these 3 terms in the inequality. Pi plus pi over 3 would end up giving me 4 pi over 3. Negative pi, going up by pi over 3, would give me negative 2 pi over 3. So, when I'm going around trying to find solutions to the unit circle, I'm trying to find where this angle, the sine of that angle, equals square root of 2 over 2. I don't have to go any further than 4 pi over 3. And you might notice that when I was writing solutions, 4 pi over 3, let's see, 1 pi over 4, 3 pi over 4, 5 pi over 4, those are all within the bounds. 7 pi over 4 is bigger than the upper limit. So I don't have to worry about 7 pi over 4 being a solution. And similarly, I don't have to worry about going up any further around the unit circle. Nothing bigger than 4 pi over 3 is going to generate a solution for me here. I do have to worry about negative values of x. So let's go below 0 and start picking up some answers there too. If I was to crank in the reverse direction around the unit circle, I already knew that 7 pi over 4 was going to be a solution. If I crank a full 2 pi lower than 7 pi over 4, that would put me at negative pi over 4. That is not lower than negative 2 pi over 3, so I'm going to keep on going. 5 pi over 4 cranked around a whole cycle around the unit circle would be negative 3 pi over 4. Oh, and I was just paying attention to the lower limit here. Negative 3 pi over 4 is already lower than negative 2 pi over 3. So I've already found a number that's lower than my lower bound, so I don't have to worry about checking anything lower than that. So it looks like the only solutions that are going to end up appearing in this problem are going to be modifications of those 4 values of x plus pi over 3. So if we just found solutions for x plus pi over 3, and those 4 solutions are negative pi over 4, positive pi over 4, 3 pi over 4, and 5 pi over 4. My last step would be just to subtract pi over 3 from each one of those 4 values. So take away pi over 3 from everything. All right. Final solutions. There's twelfths here involved. No common denominator. Okay, hold on, give me a second. Negative 1 pi over 4. If I take away pi over 3, that's going to give me negative 7 pi over 12. 1 pi over 4 minus pi over 3 is going to give me 1 pi over 12. 3 pi over 4 minus pi over 3, that's going to give me 5 pi over 12. And then 5 pi over 4 minus pi over 3 would give me 11 pi over 12. So there you have it. Those should be the 4 crossing points in my equation. If you'd like to check in your graphing calculator to make sure that these are the 4 and the only 4 solutions, you can bust out your graphing calculator and we can graph those 2 original equations, see where they cross, and verify that it is indeed going to be 4 positions. So the left side of this equation was 4 times sine of x plus pi over 3 minus 2. And I'm trying to see where does that line cross the line y equals 0. That's the right-hand side of the equation. My window, I'm going from negative pi to pi, as the domain tells me. And my y-axis, I just needed a small enough window so I could see what was going on. I went from negative 4 to 4. So let's graph these and see where they cross. I'm sorry, I didn't square it, did I? That doesn't look right. There we go, hold on. Let me insert squared. There you go. It was 4 times that angle squared minus 2. All right, hold on, bear with me. And we should be seeing 4 crossing points, and here they are, 1, 2, 3, 4. And it's easy enough to verify that those are indeed the 4 algebraic solutions that we came up with here earlier. Let's see what's happening at negative 7 pi over 12. There's my first intersection. The next one is negative pi over 12. There's my second solution. 7 pi over 12 gives me, no, sorry, that wasn't a 7, that was a 5 pi over 12 should be my third solution, and I should also have 11 pi over 12. All right, so there you go. 4 solutions. There they are algebraically. I know that was a tough problem. That's probably one of the hardest kind of things that we're going to have to do all year long. Thanks for bearing with me, and see you in class.